So let's look at a bit of a summary of differentiation, just some more examples basically to add to the list of ones we've seen before. All right, let's start with f of x is e to the power of 2x times inverse cos of, in parentheses, x plus 1. Okay, now the domain of f of x of this function here is going to be lying between -1 and +1. Okay, so the argument here, x plus 1, lies between -1 and +1. And you have to remember, for y equals cos of a function, remember cos of x, we restricted the domain to 0 to pi, and that gave us a range of -1 to 1. And so the inverse of that now swaps the domain and the codomain. And what was the range or the codomain of cos of x? Okay, the domain, the range or codomain of cos x was -1 to 1. That now becomes the domain of the inverse function, inverse cos of x. Okay, so same thing here. The domain of f of x now becomes this thing between -1 and 1. Now tidying that up, if we subtract 1 from both sides, we're going to have x lies between -2 and 0. To differentiate this, we use the product rule and choose the product rule. Dy dx is u times dv dx plus v times du dx. And we're going to choose u is e to the power of 2x and v is inverse cos x plus 1. Okay, so let's differentiate that. Well, u times dv dx, well, u is e to the 2x times dv dx of this. We go back to our tables in a previous video and we find that it's -1 on the square root of 1 minus the argument all squared, which was, in this case, the argument is x plus 1. Okay, plus v, which is inverse cos x plus 1, times dv dx, the derivative, times du dx, sorry. The derivative of e to the 2x is 2 times e to the 2x. Okay, so our derivative for this function here, f prime of x, f dash of x, is e to the 2x, pull that out front, outside of, in parentheses, 2 inverse cos x plus 1, minus 1 on the square root of 1 minus, in parentheses, x plus 1 all squared. Okay, and also the derivative now has the same domain as the original function, except that where the endpoints were included for the original function, they're not included in the domain for the derivative. The function is not differentiable at the endpoints, and that's because the limit of the function approaches one value on one side, doesn't exist on the other, and so the derivative is not defined. You can't differentiate at endpoints. So the original function had a domain x equal to or greater than -2 up to x equal to or less than 0. Now the derivative function has similar limits, but the endpoints -2 and 0 are not included. You can't differentiate at the endpoints. Let's have a look at another example. F of x is the natural log of x plus 1 on x. Okay, well, the domain of that is the argument here must be greater than 0. Right? It asymptotically approaches, the argument here asymptotically approaches 0, and the log of it, the codomain, goes off to infinity, asymptotically approaches infinity. All right. Now here, x plus 1 on x is greater than 0, or just x is greater than 0. Okay, by the chain rule, f prime of x is, now what we're doing here is we're setting this, to use the chain rule if you like, we're doing, here we go, we're saying that f dash of x, right, is df du times du dx, where we've set u is equal to x plus 1 on x. Okay, so that f dash of x becomes df du. We call this in the parentheses here u, and then we differentiate the u with respect to x. That gives us the final derivative. So, okay, by chain rule, so f dash of x is df du. Well, df du is 1 on u, okay, times du dx. Okay, so the derivative there is 1 on u. Okay, that's the derivative there of the natural log of u, times now the derivative of this object here. which is 1 minus 1 on x squared. Okay, so derivative of, if I come down here, du dx, well, that's going to be 1. Derivative of x is 1. Now, this 1 on x, we could take the x upstairs if you like, and write that as x to the minus 1. And when you differentiate that, you can have minus 1 on x squared. Okay, so that's how we come out with this one. Now let's do a little bit of algebra. Common denominator down here, x, so that's x squared plus 1 over x. Here again, common denominator again, x squared underneath both, so that's x squared minus 1. Take the reciprocal here. This becomes, tidying this up, becomes a reciprocal of this, x on x squared plus 1 times, okay, x squared minus 1 on x. Okay, we've got some cancelling happening here. There's one going from there, there's one going from there. Okay, and we're left with x squared minus 1 on in the numerator times in the denominator. In the denominator we have x times x squared plus 1. And again with domain greater than 0. All right. We've got another example. Here's another one from our inverse trig. Okay, f of x is a square root of inverse sine x on 2. It has domain. Now the domain here for inverse sine x on 2 is the argument x on 2 lies between minus 1 and 1. Remember, sine x will have a range from minus 1 to 1, and that becomes the domain of the inverse function. So x on 2 is equal to greater than minus 1, equal to less than 1, multiply through by 2, positive number, so we don't reverse the direction of the inequalities, they stay the same because we're multiplying by a positive number. So we have x equal to greater than minus 2 equal to less than 2. Now for square root of inverse sine x on 2 to exist, inverse sine x on 2 must be equal to or greater than 0. Okay, so the domain, okay, is 0 to 2. We just can't have the negative in this case because we can't take the negative as square root. It doesn't give us a real quantity, it'll give us an imaginary one, but not a real quantity, and we're restricting ourselves here to real quantities. So the domain can't be from negative 2 to 2, it has to be from 0 to 2. Okay, now f dash of x, well, you can write the square root of inverse sine x on 2 as just being all of that to the power of negative a half. To the power of plus a half, sorry. Plus a half, my apologies. Okay, so when we differentiate that, we take the plus a half out front, we reduce the power by 1, so we have minus a half, that's where we came up with that there. We have inside inverse sine x on 2. We now need to take the derivative of that because it's the chain rule situation again. Okay, so we have 1 on the square root of 2 squared minus x squared. Okay, and that's straight from the table here of table of values. Remember, where inverse sine x on a has derivative 1 on the square root of a squared minus x squared, if you remember from previous video. Let's tidy all this up, and we have here 1 taking this downstairs, negative a half, take that downstairs, becomes positive square root here, so 1 over 2 times square root inverse sine x on 2 times the original function here. And just remember, f dash of x now has a domain 0 to 2. Okay, 0 to 2. All right, that's that.